Simplilearn. Your pace, your place.
Welcome to today's session. We're going to actually cover Cloud Computing Foundation, which is a program launched by Exin. Right? This program was launched somewhere around 2012, and Exin has got a structured exam for this, which each of you will attempt at the end of this program. The objective for this program, in terms of what its coverage is, it has a lot of concepts. Right? It has a lot of concepts about cloud computing, governance, security, how do you evaluate cloud vendors, and it has a business case in terms of how you can take cloud as a prospective solution back to your business or to your customers and build a proper business case for this. So with that, let's just start and go through the agenda in terms of what we'll be covering through the next 2 days. Okay, this is the agenda for the program. So we'll be covering these aspects. We put a lot of focus and emphasis on the first part, which is where most of the learning comes in, called as principles of cloud computing. All right, and then we go on to the next section, which is implementing and managing cloud computing. We have a section which talks about using the cloud. A very important section, which is section 4, which is security and compliance within the cloud framework, right? The various governance that you have and aspects of security in the cloud, which is probably the most important factor in a business case when you actually present a cloud business case to a customer or to your business bringing solutions on the cloud. And finally, what do you do to evaluate cloud computing vendors? How do you choose cloud computing vendors? What are the various things you keep in mind? Right? What are the kind of solutions you want to keep? What are the kind of security aspects you want to keep? How do you evaluate vendors? So we look at all these aspects as part of the 2-day program. Right. The same thing in terms of course objectives. So what we'll do is this. Now this is the overview of cloud computing. And yeah, we can just go back to that slide again. What this slide emphasizes or shows is basically what we're going to study in the initial part of this course. Right? The overview of cloud computing. So there's a lot of talk about cloud computing. What is cloud computing? Right? Is it something new? Is it something that's come up yesterday, or was it always there? Right? There's always two sides to this theory. People are there that state that, oh, it's as old as probably the web. And a lot of them saying, okay, it's new, I've just heard about it recently. Right? It's actually a mix of both. To be more appropriate and right, it's probably been there from the evolution of the web itself, the World Wide Web, in terms of solutions and what's all there. You definitely had certain aspects of cloud in every aspect of the World Wide Web that we've probably experienced or influenced. Right? But let's look at it from a ground level up. Right? What do you need in terms of cloud computing? Right? You need to implement some solution. Right? That's the first step. This solution can be something within your data center, right, where you take your various components of your data center, virtualize it, and then orchestrate a cloud-based solution around it. And we learn a little bit more about this as we move forward. You are able to actually build and implement a cloud-based solution ground up within your own data center initially, right? And there are some attributes behind this. We'll study it, we'll see it, we'll read about it, probably we'll focus a little bit in terms of discussion on it. Right? Once you implement that initial part of the cloud solution within your data center, we call that a private cloud, I'll come to that a little bit later. You then begin to use aspects of this cloud infrastructure, right, to various users in your own business, right? And what are this? We'll again come to it as I move forward, but let's assume there are some people using and consuming certain aspects of this cloud solution that you have built, right? And obviously, if there are people using it, you obviously need people also supporting this environment. As you look more and more into the cloud, we see that the aspect of the cloud is more of self-service based operations and user functionality. So you will find less and less of support coming in hand, and you'll find more and more of managing the cloud solutions, right, as you go forward. And again, as you go forward, you will also have more and more options coming about in terms of using what is available in your data center as far as the cloud solution goes, and then using those options along with what is out there in the public space, which we call as the public cloud, right? And probably integrating the two together, which we bring out a term called as the hybrid cloud. So you will use various methods of evaluation to see what works, what's more efficient, right? What's right for the business, right? These are some aspects that you'll focus on as you move forward and as you grow towards the true definition of cloud computing, where It's completely available on demand. It's on the web, and it has its own monitoring mechanism. It has its own metering mechanism, and that's where you want to see a true cloud-based solution. So you start ground up from your own data center, and as you move up, right, you look at various aspects of value adding into that particular solution that you built in your data center, and as you mature, you get more and more onto various solutions that you can subscribe straight off the World Wide Web, right? And utilize those solutions as part of an integrated cloud solution, which we call as the hybrid solution, right? And so we will study all of this in some depth in this module as we go forward, right? And let's move to the next slide. So let's look at the principles of cloud computing. Yeah, we keep moving forward. These are some of the things that we see. The concept of cloud computing, the evolution towards cloud computing, the history of the cloud computing architectures, benefits and limitations of cloud computing. Alright, so these are some of the content that we'll cover. As I said when we started this program, most of the conceptual topics in terms of understanding aspects behind the cloud comes in this section. So we will put a lot of time and effort in trying to understand each of these modules as we go forward, right? And hopefully each of you will be able to understand and assimilate this information as we go forward. Okay, so the overview and concept of cloud computing, a question that I asked earlier, is it new? Is cloud computing new? The answer is yes and no, right? And to bring the essence behind cloud computing, we look at this model that's presented out here, right? At the base, when you talk about cloud computing, you actually are talking about virtualization. Right, so this is an overview and concept of cloud computing, right? At the base, what we have to build a cloud computing environment, right? And this is where we bring out the whole debate about how old is cloud computing, is virtualization, right? Now this is the layer with which you actually build solutions towards the cloud, all right? What is the cloud? We'll see now. So virtualization as a concept has been pretty old. It's been there in the 60s. In fact, IBM started the concept of virtualization with their mainframes around that phase and the time. So it's as old as the 60s. Before you or me were born, right? But what made this concept popular today, more popular today, is the evolution of, I would say, the integration and evolution of two aspects. One is communication, which is the internet, the World Wide Web, right? And two is the acceptance of standards in the world today. And particularly if you look at it today, most of the networking components have a certain standard that they follow. Most of the architectures in terms of hardware, we follow certain standards. And virtualization actually took popularity in the modern day, that's today, with the x86 boxes, which means the boxes that Intel developed, primarily the Intel-based processors and their clones, right? So virtualization as a concept took on from there. So we had virtualization and is the foundational kind of building component behind the cloud. So you virtualize an environment out here, and the environment we'll define a little bit more in detail as we go forward, but an environment can be the infrastructure, can be the hardware, can be the storage, can be the networking components. On that, you could also virtualize aspects of the application, the database, right? You could virtualize an end product in terms of a solution. Right? Let's assume virtualization is built and we started out, and so from that perspective, we then go and say, okay, once you virtualize, what do you do then? You virtualize and then you begin to share this virtualized environment out here to your customers. And the idea of virtualization is that this one single component is now split into multiple virtual components, right, which can be shared. So you're kind of utilizing that particular component more than it would have probably as a standalone kind of mode, right? And so with virtualization, what also gets added on is the factor of scalability. Now it's all a matter of you adding on more virtual components, right, in an environment and scaling this virtualized environment up and in turn building a service. And this service today, you want it to be accessible through the internet, right? And basically, if you can bring this whole virtualized environment as a service through the internet, you're getting it moving towards cloud computing. Alright, so that's how the overview of cloud computing can be talked about, but again, it's just a one slide kind of model. We will go into details behind each of these, right, and talk about it in some more depth. So some definitions straight out of the book. What is cloud computing, right? A small definition from the encyclopedia in around 2012, this definition came out. But the more accepted definition is what we're going to read now. It's from the National Institute of Standards and Technology from America. Right? It says cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Example, networks, servers, storage, applications, and various services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Right? So a lot of words. What does it mean? So if I can take this as an example, the first step and most important step in cloud computing is it should be available, right, to a user, generally over the web-based platform like a web browser, right? And the availability of resources should be across, as he mentions here, a pool of configurable computing resources. Now, so can a user sit across the web and say, okay, I want a server available? It's as simple as that. Can you sit across the web and say, I want a server, and this is the kind of configuration I want the server? Can the user sit across the web and say, I want a database available, right? Now the database can be available for my computing use, the database can be available for my development work, right? The database can be available for an integration with an application of mine, but can it be called for and subscribed for straight from the net, right? So the idea is these configurable computing resources, as the word is used here, is something that is available to the fingertips of an user on the other side of the web browser, right? That's the big difference that we will see in cloud computing today compared to a period earlier, where you and me probably didn't have access to these computing resources directly through the web. Today it's available, right? Now, these resources itself are available because someone has virtualized that environment in the back end, right? Somebody has done the behind the scenes kind of work and kept that resource available, configured in such a way that you and me can now subscribe these resources from the net, right? So there's a lot of work that's happened, and that's the step that we kind of briefly highlighted and talked about earlier, where someone has to build this cloud environment. Now that's built and given. The next step is you consuming it. So when you consume it, it's this. So you can say, hey, I want one database instance, I want 10 database instances, I want 20 database instances. You can also say, I want one server, I want 10 servers, I want 20 servers. I want a server with 5 CPUs, I want a server with 2 CPUs. So, or things like that. You can define aspects here and then choose to build your pool of configurable computing resources, right? So, can it be provisioned immediately? Yes. That's another aspect of cloud computing that we will study. So I want it to be available now. So can I get my server immediately by a click of a button on the web? The answer is yes, right? And once I've done, used, and felt that, okay, the purpose of this resource is completed, right? The outcome is achieved. Can I release the resource back? The answer is again yes, right? So that's where the rapidly provisioned and released with minimal management effort comes from. Right? So think of it today. How are you actually accessing resources across the web, across your environments if there is a need for resources? You would generally place a request in your workplace. You would say, okay, I want a server, I want a desktop, I want this operating system installed on it, I want a database installed on it. It could be for a test environment, it could be for a development environment, it could be for a customer demonstration. Now, once you place this request in your environments, what happens? It goes through a whole process behind approvals, provisioning, somebody in the back end supporting the logistics, and then getting this whole product or solution to you physically, right? And obviously, once somebody gives you this product or solution, you also need people to manage and administer this product and solution, correct? So there's a whole lot of processes and overheads behind you asking for these resources currently from your workplaces. Now, what the cloud does is kind of takes away the entire process that you normally would go through, right? With time. Obviously, these things don't come overnight. It takes time for you to get all these things. With time, it takes the entire thing away from you and your organization's overhead and passes it on to a cloud provider. So you can go to a cloud provider today and ask for the same things, and it gets provisioned for you within minutes. It's as simple as that, right? And that's what this particular definition and why it stands out is because as I just explained, covers these main aspects that we just discussed. Right? So again, I read it again. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. And those resources can be any, just a few examples like network servers and applications. Right? That can be rapidly provisioned and released with minimal management effort or service provider interaction. So this is a big benefit, and this is a great example and definition of cloud computing from the NIST. Okay, so now we come to certain attributes of the cloud, right? And we call these the characteristics. I use an easy analogy to remember these things. So a cloud solution, right, must have these 5 characteristics, and that's how you can define that's a cloud solution. Okay, so people have asked, what is cloud solution? So the answer to that would be this 5 characteristics. So you can answer back, or you can ask questions back. Does it have an on-demand self-service? Alright. Does it have resource pooling, which is the word we use today is multi-tenancy, from a consumer perspective? Okay. Does it have elasticity, rapid elasticity? That means flexibility and scalability. And is that a measured service? Now this is more from the provider's perspective, that is paid per use, more like a metering service. And is it accessible from anywhere when I have the connectivity to the net? So the broad network access factor comes here with any time, any place, any device. The device can be a laptop, can be my desktop, can be my mobile phone, for all you know, right? Is that particular computing resource that I want available to these devices once connected on the net? All right. So these are the 5 characteristics. So let's look at it. On-demand self-service. What does it mean? Right? Taking the example of you procuring a server as an example, right? Maybe let's be specific with some technical detail. You say, okay, I want the latest Intel-based server with 2 CPUs in that, and maybe 4 GB of RAM. And can it provide me 1 terabyte of data? It can be as big as that, right? Can it provide me 1 terabyte of data? And can it install the latest version of Red Hat Linux? Correct? Now, if someone says, okay, let me get all these things for you, but I need somebody to administer it, I need somebody to manage it, I need somebody to install it, right? Because you're not going to be one-shop technical man doing everything, right? But on the cloud, you want that available. That means on user demand, I click a button and say, this is the kind of specification I want. Generally, the service provider who gives you these services will have a catalog of predefined images of these servers, if you take server as an example, right? And you can just click and say, okay, I think this particular server type is what feels right to me. Yeah, it has similar specifications to what I asked for. And you can click and choose it yourself by just taking a button and you subscribe for it and say, okay, I want this server. As I just specified, it has these particular hardware specifications and this OS specification and this memory specification. Can be built for me through the net? The answer is yes. So it's on-demand self-service. So me as a user or a consumer of this service, which I call today as an infrastructure, as a service, I've just clicked and asked for a server to be available to me immediately. In a matter of a couple of minutes, you have the server actually built, ready, and given to you on the internet. When I say on the internet, it's somewhere out there. Physically, the server is somewhere out there, right? But obviously, at the back end, that physical server is not visible to you, right? There could be an aspect of that server being virtualized, resource pool, utilized at the back end through a data center, which is also virtualized, and it doesn't matter to you. You don't care, because for you got a server available by you just clicking a button and saying, I want the server to me right now. And the server is ready, built, given to you with access, password, security, everything presented as though you were the administrator of the server. And now all you have to do is ensure that you are connecting it to the server. So how do you do that? You do that through any other means, like how you would do it even if you have a physical server. You need a desktop to use it and connect it across the network. Use the authentication mechanisms to log in and then get access to the server. So it's as simple as that. The same thing happens here, but it's going to happen through the web. So you have the server built, given to you with the details of login and authentication and permissions and everything that is needed for you to set up and run the server as per your own needs. Alright, so that's on-demand self-service. So that means you have asked for it and you have got it. Correct? Nobody has helped you. It's just an option that's there on the web. Somebody has presented a catalog of items saying these are things available. You choose what you want, self-service. And it's ready. Right? The next aspect or characteristic of cloud computing should be resource pooling or multi-tenancy. Now, this is in particular with solutions that have links and as we move forward, the service models we talk about, like platform as a service, or even if it's an application, or even if it is an infrastructure solution, right? The idea of multi-tenancy is that more than one user can subscribe for that same solution, right? Without interfering on or without stepping on the solution of another user who is also subscribed for this solution. So the idea is you are able to provide the same solution to multiple users through the web as though each user was consuming that service in a dedicated mode, without knowing that there could be actually hundreds of users consuming that one particular service, right? And that is multi-tenancy, where you're actually stating that this particular cloud-based solution can host, right, different sets of customers, right, even though it is a single instance of a solution available on the web, right, which we call as a cloud computing solution. And keep in mind, now these are where aspects like security and other things come in, but an effective cloud solution should be able to segment customers out, right, using the whole aspects of virtualization and management in the backend. Again, it should be transparent to you. You as a user need not know about it, but a key characteristic of a cloud solution is that it is multi-tenancy, right? Third aspect or characteristic of the cloud is rapid elasticity. It's a word that is used very strongly, very popular, elasticity. Elasticity is like, if you take an example like a rubber band, right? If you stretch it, it stretches, if you release it, it shrinks back to its whatever, so-called original size, right? So with rapid elasticity, you want flexibility and scalability. Now what does this mean? A cloud solution should give the consumer of that cloud solution the ability to expand and the ability to decrease, right, at will. So it means that, okay, in an example that I can take for a cloud solution is, let's assume you're building a web portal for e-commerce and you're trying to sell some solution which could be gift items, right? And the closest you can take from here is the retailers like Amazon and Flipkart and these players out here. Now, one of the challenges that the IT team faces out here is actually sizing and keeping capacity of their components that run their data centers, right? And this is important. Now, why is this important? Because these businesses, for them it's critical that they support volumes on need basis, right? So that the business can achieve its targets, which means, let's say, a seasonal goal, let's say a holiday season, right? You have a lot of people coming and booking and taking a lot of gift items online. It need not be that this workload remains the same throughout the year. You may only get these huge workloads coming during these holiday seasons. And in India, we have a lot more holiday seasons than the Western world. But assuming if we take this example with, as well, I talked about e-commerce-based gift shop, and closest I can think of is, let's say, Flipkart. During Diwali, you may get a lot of people coming and making bookings and orders, a lot of things online. Now, this creates load on that infrastructure that supports this business solution, right? Which means, okay, it's an application that you're seeing, it has e-commerce, it allows you to choose a catalog of items for books, it allows you to put it onto your shopping cart, right? There's a whole technological aspect behind this, right? The end product is what you're seeing, but you're subscribing for it. Now, when I talk about rapid elasticity, you want your solutions, like this particular portal, to be available on greater demand and to be available even on lesser demand. And to be available, you need an underlying infrastructure and a solution behind that infrastructure that can use more resources and components to support that load that may come up, right, during peak periods, right? So you need that cloud solution to enable and showcase rapid elasticity. That means you want to expand in terms of memory, you want it to expand in terms of storage, you want to expand in terms of its network capacity, you want to expand in terms of compute capacity, which means more CPUs. You can get that, again, all these options available for you at a click of a button, plus customized for you within the applications through APIs and other aspects. right? So you need that particular cloud solution to display rapid elasticity, which means grow on need basis, and when the need is complete, releasing those resources to go back to your normal requirement. So that you're not actually holding on to unnecessary capacity when you don't have the need for it, right? So that's the basic characteristic that makes cloud solutions very popular, right? The rapid elasticity. Measured service, more from the provider's perspective, but important from the consumer's perspective also, where you're actually being billed for the resources that you use, right? And for the time period that you use only. Okay, it's a very important aspect. So again, I go back to the example of servers. If you have a requirement to buy a server, right, whether you use it or not, that is capital expenditure that you have actually put in, and the server is kept and given to you physically. Now you can say, okay, I've done my testing work, I've done my development work, and now I want to release the server. Who's going to take it back? I mean, it's a material that's there and procured for you, right? Unlike in that scenario, in a measured service, you pay for only what you use. So you say, I want to use a server for a particular purpose, building an application, maybe deploying a solution, maybe showcasing a concept to a customer. After you finish with that outcome, you begin to release these resources back. When I say release resources back, you can give it back to the provider because it's a solution on the web. And these solutions on the web have these functionalities which states that you are going to be billed and charged for only the period of time that you actually use that particular service. So that's again a very important characteristic behind the cloud solution. And lastly, which I already explained, this permission should be available using a web browser and a network connectivity through the internet, right? And it should be available on your mobile phone if you need to. It should be available on your tablet if you need to. It should be available on your laptop or your desktop. So anytime, any place, any device, obviously the constraint being that network access should be there. So if a solution today can answer these 5 characteristics, that's a cloud-based solution. So if someone asks you, what is a cloud-based solution? You ask them back, does it have on-demand self-service? Right? Does it have multi-tenancy functionality? Is it rapidly elastic? Can I scale up and scale down? What kind of flexibility it gives me? Is it a measured service? That means I get to pay for only the time and the resources that I use for, and then I give it back. I don't get charged for it. Right? I'm not actually putting in a large capital expenditure to procure all these solutions in terms of components that I want for the solution. And obviously the last part is it should be accessible on the net. Okay. Yeah, these are the 5 characteristics. Okay, so by looking at and seeing that explanation, it becomes more right to say, can I look at IT being a utility today, right? And Vivek Kundra, who's the federal CIO for the United States government, put out a statement there. He says, what do we see with cloud computing is what happened with things of utility at home, like your water supply, like your electricity, like your equipment that you use, without even knowing the kind of technology that's there behind it. Like when you switch a button on, right? You want the lights on, you want the AC on, you want the fan on. But do you understand that the entire thing is driven by electricity, which is actually generated through, let's say, vast amounts of technology, resources, natural resources, and other things at the back end? You don't need to know that, right? That's all there. And what's happening today is it's a utility service that you just click a button and you have lights on. It's the same logic that people are bringing towards computing today through cloud, right? Where you just want something and you're not worried about the technological aspects behind that particular need of yours. It should be available if I want it, I'm using it. And for the period of use that I'm keeping, I'm being measured, metered, and charged for. And when I switch off the light, as an example, in the utility service at home, when I switch off my light or my AC, I'm saving on my electricity bill. The same thing is going to be true with cloud computing, he says, in the same logic. So this aspect of utility, if you make an analogy, you can link the analogy to electricity, you can link the analogy to the water supply that you get at your homes, right? You open the tap, water is on, you close the tap, and water is off, right? It's the same belief system that we can get cloud computing resources through the web in a utility form. So cloud computing, some examples, and this is where each of you would have had some touch point. right? So are these aspects of cloud computing? Definitely yes, right? Did you know about it? Maybe, maybe not. Most of you would have considered them as web-based programs or web-based applications or just a social media application, right? So here are actual examples of cloud computing where you have Facebook, Twitter, which is social media, the various wikis, you have various online games, you have Hotmail, which is the webmail, you have Dropbox, which is a storage capacity. For businesses, you actually have various applications. You have CRM applications, backup services, ERP applications, financial applications. So you may ask, hey, what's the big deal? All these things don't sound like cloud. Okay, for the business it does, but all these things don't sound like the cloud. These are things that are used day in, day out. The answer is that's the cloud, right? And if you go back into the characteristics, you can definitely ask the same questions here. And these are just some examples of something that you have consumed as an application, right? Which we call as software as a service. I mean, if it's an application that you consume for some purpose, social media, right? That's software that has been provided as a service through the World Wide Web, right? And you are not worried about the underlying technological layers behind that particular solution that is presented to you. So if you take Hotmail or Gmail, do you ever consider where is that particular mail server kept? How is it connected? In which data center it is kept? What kind of softwares run that particular mail server? Who's backing up that mail server? How are they creating the technology to send messages? No, you don't. For you, it's a matter of you logging into that particular ID, which is the Gmail ID, and then just type in your mail and clicking send. The message has to go. The idea is the message has to go if I click send. That is the expectation you have. That's the outcome. And this is where cloud computing is coming. Cloud computing is coming and saying, hey, we are going to do this. We provided the outcome. You tell us what you want. We provided the outcome. You don't worry about the technological backdrops behind this outcome. That's something that we, as a service provider, will take care. So you, as a consumer, now will just subscribe for the outcome. Okay? Yeah. So you have the 5 characteristics that define the cloud. Now, so anybody asks you, what is a cloud solution? You validate that against the 5 characteristics. And once that is done, you go to the next step. Now, how is the cloud actually deployed out there in today's world and today's scenario? Okay, there are 4 deployment models in the cloud. Very popular models, which people talk about and most of you would have heard about also, right? You have the public cloud, you have the private cloud, you have the community cloud, which is a little bit of a mysterious thing, which we'll explain now, and you have the hybrid clouds, right? So, what are these? These are the 4 deployment models that, as of today, is accepted by the industry. All right, into what and where the clouds can be deployed. So let's start with private because that's what is probably the easiest to understand. So you have the belief system of an on-premise data center, right? Most enterprises have it, most businesses have it, large corporations have it, right? It is on this in-house data center that you begin to take your first few steps towards cloud computing, right? And to do that, you need certain technological products and components at the layers that allow you to virtualize your data center and then bring it up to a cloud environment. Now, this cloud environment that you build within your own in-premise data center is normally called as a private cloud. All right, that means only users within your organization can subscribe for the services through this cloud service. Okay, and hence it's called a private cloud. It means that you and me who are outside the organization, right, or anyone who's outside the organization cannot subscribe to the cloud services of that organization's private data center. Alright, it's very simple and easy to understand. So that's why it's called a private cloud. Okay. So you may ask, if somebody is building a private cloud, what benefits are there? The benefits are the 5 characteristics that we talked about. Right? Even there, in the data center, if you begin to provide self-service mode solutions, you begin to provide rapid elasticity, right? You begin to provide a metering service for the various businesses, the services that they use, right? You're actually giving them an aspect of the cloud that they need to use right now, and they don't have to go through the whole approval mechanism, physical procurement. In most data centers, invariably what happens is that people have procured a lot of physical equipments which are underutilized. Right? And so by moving towards the private cloud, which means first step virtualize, second step get onto the cloud using cloud-based tools, you're actually effectively utilizing your data center a lot more and better. Alright? So that's the first step. So you build a private cloud. What's the public cloud, right? The public cloud is an offering that is given by vendors to the net, right? And these offerings can be solutions like the most easiest solution to understand is Gmail, right? It's available on the World Wide Web, and anybody can subscribe to it, right? It means it can be you, it can be me, it can be someone across the net who's just going and logging on for the first time. Anyone can subscribe for it. So a public cloud is an offering presented to anybody who wants to subscribe for it from the internet, right? That's the public cloud. So you have a lot of computing resources on the public cloud. Classic examples I talked about is products like Gmail, Hotmail, Dropbox. These are all functional needs and uses that are being given to users on a subscribed basis, right? So the public cloud is logic. If anybody can access it, if you subscribe for it from the net. Okay. And then you have something called the hybrid cloud, which I'll talk about before getting to community. In a hybrid cloud, the benefit of public cloud is passed on to the enterprise. Now, in no enterprise, when I say an enterprise, it could be a bank, it could be an organization, it could be a company. No enterprise would want its entire data and infrastructure on the public cloud, because of various reasons. There could be governance reasons, there could be security reasons. So no company would do that. But can they take certain benefits from the public cloud and integrate that with their private cloud, right? And if they can do that, we actually call that structure of deployment the hybrid cloud mode. So the hybrid cloud is a mix of an in-premise private cloud integrating with certain components that are available on the World Wide Web through public cloud providers, right? And that becomes the hybrid cloud, and that's how this particular slide is trying to showcase it, where the private cloud internally can subscribe for certain compute resources available on the public cloud. Where does this come in? What kind of modes we can use this? And just to take an example so that we can understand this better, right? In a data center, one has resources available to a certain extent. I mean, even there you can't invest to infinity. You cannot go on buying the best resources, the best servers, the best applications forever. There will come a time when businesses decide that, hey, it's getting too costly for us, right? It's getting too expensive for us to keep these kind of products and solutions here. So is there something by which I reduce my capital expenditure and start looking at subscribe modes for certain components that I need for a limited period of time, right? It could be, if I take an example, right, most corporates, right, and most enterprises would have in-house development teams. These in-house development teams would be there to develop maybe their legacy applications, their in-house applications, customization of the applications. Now, these development teams eventually and inevitably always need resources. In terms of maybe the next version of the release, right? Maybe an upgrade, maybe a bug fix. They need resources. And these resources are capital intensive. So they always go back to the business and say, okay, for the next release, we need this kind of a hardware, we need this kind of an OS, we need this kind of a database of that particular application. If I'm going to maintain, I need this kind of the latest technology available to me. So the businesses go about investing in this. Now, here's where you can build business case scenarios stating that, okay, for the live environment, let's invest all this. But for your test environment and your development environment, right, if you want to showcase these things and test and do a little bit of R&D, why can't we explore certain of these compute resources being subscribed from the public providers? All right. So that's where you have this leakage and combinations coming in, where information that is less critical to an enterprise can be integrated with the public provider of a cloud service, and in that form build a hybrid solution, while the developers still feel that he needs resources, he gets it immediately, right? He doesn't feel a difference of the aspect of that solution being provided to him. In fact, he may get it more efficiently coming from a public cloud provider than his own in-house data center or his private cloud. Right? So this is just an example. The other thing would be is when a company decides that, okay, I keep all my financial data with me, right? I keep all my critical information with me. There are governance, there are regulatory needs for that. So it will be there in my own data center, it will be there in my own private cloud. But maybe there's a customer-facing website, which is not necessarily maybe an e-commerce website, just a website of the company, a corporate website, right? Can we host that website on a public cloud? Right? These are particular solutions that businesses can think of today, and then subscribe for that hosting service through the public cloud. All right, and again build a hybrid cloud model. So that's the three models that we discussed: public, private, and hybrid. So what's a community cloud? I mean, it's a very tricky question when there's a question that gets linked into your exams most often than not. It sounds nice, community, right? And what does it mean? Now, in an environment where there's public, private, and hybrid, right? In each of these three environments, there's a lot of investment that needs to go in. Right? The largest investment will go into the public cloud, right? To set up the infrastructure and the solution. Right? And the next obviously will be the private cloud. Now, even a private cloud solution is not going to come cheap, right? There will be a situation where people feel to set up a private cloud solution, it's expensive for me even in-house. What do I do? Right? Is there an option by which I can actually begin to share resources? When I say resources here, it means capital expenditure, it means money. Can there be a method by which we can pool money together and build an environment private to us? Right? And a community cloud comes in over there. It's very applicable in environments which are not for profit, like an NGO or a so-called educational institutes, right? Where the educational institutes pool resources together, right, to build a private cloud that they can subscribe among their community only, which is the academic community, which is the student community, which could be the university, linked to the colleges, right? And so the idea is to build a private cloud with shared resources from a group of users that have similar thinking and has a similar purpose and an objective. Right? So it's more apt in environments like we see today. It's more in the academic side. So you would have institutions linking up with universities, and for that you have universities passing information up and down. You could have the entire resource management system working through that, right? But the difference now is, even though this is a private cloud, it's a group of people that have come together and put this private cloud together, all right? And these resources that they have pooled is basically money. They have put their money together, pooled it together, and built a private cloud which is being consumed only by this community set of users. Okay, we're seeing the 5 characteristics of the cloud. Right? So if I put the cloud as an environment out here, there are 5 characteristics that we talked about earlier, right? We've seen the 4 deployment models, or we have talked about it. Alright, and now we come to an interesting aspect called as the 3 cloud service models. So there is a 543 thing here which will be used. 3 cloud service model. Alright, models. In the sense, there are 3 cloud service models that are very popular. And we will touch upon each of them now in this particular section of the discussion. Okay. Everybody would have heard of these terms. SaaS. If not, let's hear it now. It's called software as a service. Alright. PaaS. Okay, again, as a service remains the same. It's platform as a service. And IaaS, alright, which means infrastructure as a service. Okay, so the most common thing that people use, when I say use, is software as a service. Today, it has a touch point with everybody, as I talked earlier, whether it is a Gmail, whether it's a Dropbox, whether it's a Twitter, whether it's a Facebook, right? These are all ready-made applications available on the web for a particular purpose. The purpose is social media integration, social interaction on the web, right? You can use it for your marketing collaterals, you can use it for your business collaterals. Now these software or applications are ready-made and available to you for you to consume. Yes, most of these services are free. Right, so you don't get charged for it, and hence the metering mechanism need not really be applicable in terms of a cost, but they do meter you. Like for example, if you go into Gmail, it tells you, okay, how much utilization of space have you used, how much is available even more, though it is infinity, they do that as a service, right? So that is software as a service. You and me have consumed it, you and me have had touch points with it, and we know a lot about it, right? Like this, a developer can actually create an application he wants to and deploy it on the web and allow it for anybody to consume, which showcases those 5 characteristics that we talked about earlier. He's actually building a software as a service, which is there on the web. Okay, the next step is platform as a service. It's not something that everybody hears about, but this is again something available on the web today, where you can have an entire development platform built for you on the web and available for immediate use. And when I say development platform, it would be mainly development towards building softwares that you want to deploy or applications that you want to deploy on the web, right? So what are these platforms? Now, in a normal development environment, right, you need these platforms, and these platforms could include obviously the operating system, it could include the tools, it could include the compilers, it could include the databases, it could include the web engines, alright, that you want in terms of publishing a website. It could include an application server, okay. So a lot of components, right, and obviously infrastructure. You need infrastructure to support the OS itself, with networking and other things available, right? A lot of components are put together for a development team, right, to build a particular application or a software, all right? What platform as a service does is it allows you to subscribe for a platform from the World Wide Web. So you don't have to go about buying these tools, buying the database, buying the various compilers, right, buying the infrastructure and setting it up in-house for your development team to work. And then obviously you need to develop, roll and deploy these applications. So you need to have a web server instance, you need to have an application server instance. Now, can this whole thing be packaged and presented to the development team as a whole platform? Alright, and that is called platform as a service, which is today a critical and important component that is being used, right, in the development of web-based applications and solutions. Right? Now this itself is a service that can be subscribed by you or me, right? If you want to develop an application by yourself, it does not require large-scale investment, it does not require large-scale technical know-how, as long as you understand how to code it and ensure how you want to deploy it in terms of solution on the web, right? Because you get the entire set of tools and platform that you need to develop your application on the web, which you can subscribe for. And probably the least known or seen part of the cloud service model is infrastructure as a service, but it's the easiest to understand, right? As we talked about earlier, if you want a server up and running, today, if you want a server up and running, you have to go and buy it, right? You have to buy an operating system, you have to obviously buy the hardware, you have to buy the warranty, you need to have a system admin supporting it. How about passing that on to the provider? So the provider says, you come on the World Wide Web, right, on the internet, and here's a list of things I can provide for you. I can provide for you servers, I can provide for you storage, I can provide for you network infrastructure, I can provide anything that I have already listed in my catalog of items. You just choose what you want, and I'll build that server or I'll build that component for you. And how long does it take to build this component? Normally it takes minutes. In a matter of minutes, you can have your server up and running on the internet. Now what you do with that server is up to you. Now you may want that server as part of a test environment, you may want that server as part of a hosting requirement, you want that server for moving some of your legacy applications. It's up to you. This server would normally get built with an operating system that you specify, okay, through that particular provider's catalog listing, and that particular server is given to you. And it can have the kind of storage capacity you want to have, it can have its own firewall settings, it can have a lot of things that you normally would do with your own server in-house. Correct? So these are the three various cloud service models that are quite popular and known in the industry today. Right? The SaaS as a service, the PaaS as a service, and IaaS as a service. So for the cloud, you will have the whole story pitched in these forms. So you must have the 5 characteristics being displayed in the cloud solution. You will see the cloud solution in one of the 4 deployment models that we talked about. And in those deployment models, you will see these various service models of the cloud. Either you are subscribing to infrastructure as a service, either you're subscribing to platform as a service, or you're either subscribing to software as a service. So this is the various areas in which you begin to use the cloud. Yeah, we can just go to the slides in terms of the presentation, and this was just a quick overview of it. So as we go to the slides, you can see a little bit more.